Welcome to the NGSS virtual crash course. You're just starting Module 1, which is NGSS Shifts in Teaching and Learning. By the end of this unit, you'll understand some of the differences for students that are going to be learning in an NGSS environment and some of the implications for you as a teacher of NGSS. We're going to be starting with Lesson 1 of this module, which is Comparing NGSS with Other Science Practices. Before we get started, I'd like you to think about this norm for the course that we propose, which is a commitment to unlearning. Up to this point, you probably didn't learn in an NGSS environment, and you probably didn't learn to teach NGSS in your university or in your college experience or your training program. NGSS is relatively new in the world of science learning. It was published in 2013. So you might find some things in these courses over the next couple of weeks that push your thinking, that you feel resistance to, or that you question, and that's okay. What you do with this course really is up to you. So one thing that you could do as a result of this course, if you're a person that likes trying new things and taking risks, you might end up creating an entirely new phenomena-driven 3D unit of NGSS. You might pick a few things up, try to gradually adjust your lessons and units, or you might decide that you really like one thing about NGSS and just start trying to make targeted adjustments in each lesson with that one thing, such as a cross-cutting concept or a science and engineering practice. Now, before I use too many of these NGSS words, they're famous for the jargon, let's take a look at the learning objective for today. Our learning objective is I can compare and contrast NGSS with other science practices. To accomplish this learning objective, we'll look at this intro video. You'll have time to explore two resources, the New Vision and the NGSS screening tool. You'll post on a Padlet with your Job-alike group, and there will be some additional resources that you can take a look at if you're still interested in learning more. So if you're brand new to this learning, I'm going to ask you to make a prediction, or if you are getting your feet wet with NGSS, you'll be connecting to some prior knowledge that you have. You can grab a piece of paper and a pencil, or you can jot this down on something that you have open in your computer. But take a moment to think about, what do you think? What about NGSS is the same as other science teaching and learning practices? And what makes it different? Go ahead and pause this video while you're thinking about that. So one of the most surprising things that people learn about NGSS is that it's actually not a curriculum. Teachers or programs are responsible for resourcing this research-based framework. This framework is meant to be student-centered, collaborative, and hands-on, and it should drive a three-dimensional approach to 21st century learning that prepares students for college and career readiness. You're going to be learning a lot of new terminology in Module 1, but some of the things that you'll hear over and over again really relate to this idea that NGSS is a three-dimensional approach. So pictured there's a picture of a rope, and you can see each part of that rope has a different name. First, we have the science and engineering practices, or SEPs. These are some of the performances of skills that students will be flexibly using throughout their learning. Next, we have the cross-cutting concepts, or the CCCs. These are the ways that students are thinking, often transversely, about science. And finally, we have the disciplinary core ideas, or the DCIs, which could have traditionally been referred to as your content, although in NGSS, the DCIs are explored through problems and through phenomena. So let's take a moment to really look into the teacher's role in NGSS. It's possible that you're doing many of the practices on the right without having already adopted NGSS. You may just consider some of these good teaching practices. It's also possible that your school may have informally or formally adopted NGSS, but you're not doing the practices on the right yet, because we know that many schools that adopt NGSS have not had significant training in order for teachers to understand three-dimensional learning and the major shifts in teaching and learning. So on the left side, you can see some characteristics of not just traditional science classrooms, but many different types of traditional classrooms. You can see that those tend to be more teacher-centered, that there tends to be one lesson that fits everybody. If it's a science class, it may involve what we call cookbook labs, where they rigidly follow the scientific method with everything pre-decided. And especially in secondary, we may find that the teacher is a content expert for the class, that the teacher knows everything about science, and they lecture and they share all that they know with the class. As we shift towards that right side, where we're seeing NGSS come to higher fidelity in that environment, the teacher-centered moves into a student-centered environment. Instead of having one lesson that fits all the students, the teacher becomes a manager of different student design investigations. There's different possible outcomes to what students are doing, unlike a cookbook lab, and there's lots of scaffolding that makes it work for all different types of learners. And on the bottom, the teacher moves from being the content expert to a person that uses their knowledge and their craft to curate phenomena and resources for student learning and to push their skills in thinking for the class and beyond the class. So here's a few visuals for what that progression looks like. No worries, you might be a sage on the stage, or you might have some beloved teachers that were also a sage on the stage that really inspired you. But what we're working to bring our practice closer to is being guides of curiosity, where we show students phenomena, we get them generating questions, and we are dedicated to helping students make sense of phenomena. Or that we get really good at posing complex problems, where the teacher is designing units so that students are problem solving and sense making together in collaborative teams. The next element we'll look at is instruction. So on the left side, some of the classic ways of instructing are textbooks, possibly using worksheets that involve rote memorization. You may be using isolated science topics or units that you feel like you have pressure to cover throughout the course of the year, and you may be using the scientific method. As we shift towards NGSS, those textbooks and worksheets turn into content knowledge that's constructed through phenomena. There's many different ways that this can look. There may still be moments where a worksheet or a textbook appears, but it's going to look a lot more like a conversation and having intentional graphic organizers where students are organizing what they're observing, what they're wondering, and what they're seeing. Those isolated science topics that you have to cover, those become connected through the CCCs, which are the cross-cutting concepts. So teachers are going to find ways of thinking about questions, problems, and investigatory phenomena that put all of the science topics into a network for students to understand common themes and ways of thinking about science. And this is the main one that really surprises teachers, because we mostly all learned with scientific method and we're taught to teach scientific method. That actually switches into flexible and intentional use of the science and engineering practices. And John Mark will tell you more about that in lesson 1.3. So what does that shift in instruction look like? We've got one of the physical science standards from 5th grade, conduct an investigation to determine whether the mixing of two or more substances results in new substances. In one of our more traditional classrooms, or a classroom where NGSS shifts haven't occurred yet, that could look like a teacher demo. The teacher is going to show the students how to make the new substance and explain how that happens. Moving a little bit farther away from that, we have a cookbook lab where it's a bit more hands-on. The students are in charge of writing things down on a scientific method lab sheet, and they still have to understand how those materials create a chemical change. Now in our NGSS classroom, the teacher is a three-dimensional instructor. So they know that the student needs to conduct an investigation and have some voice in what that investigation looks like. They know that they're working with cause and effect, so they're going to use some type of methodology to teach cause and effect so that the student can use that in their determination of whether the mixing of the substances results in a new substance. And of course, they're going to capture that content through some type of phenomena before this investigation occurs. Finally, for assessment, on the left side, a traditional science classroom might include tests or quizzes or worksheets where students have to show rote memorization of facts and terms to show that they understand science. There may be closed-ended questions or things that require yes or no answers. And you'll probably see evaluations that are primarily content-driven. As we shift into NGSS, many of our tests, quizzes, and rote memorization closed-ended tasks transform into authentic tasks that are complex enough to not just yield a yes or no answer. Students are going to be flexibly using those science and engineering practices to develop their own explanations of how things work, show their reasoning, create arguments, and design models and solutions in order to show their thinking. Their performance is not just going to be evaluated on the content of science, but also how they think and what they're able to do with it. And that's where the 3 dimensions come into an assessment task. To provide an example for our life science teachers out there, this is a middle school life science standard that says develop and use a model to describe the function of a cell as a whole and ways parts of cells contribute to the function. So if you're in a traditional classroom, you might think that a worksheet, a content-based worksheet where students match the name of an organelle to the description of what it does, would do the trick. As we add the science and engineering practice, we notice that the student needs to develop and use a model. So the classic cake model where everyone brings cake or food so that they have a representation of a cell in the form of food will get you partway there. But because NGSS is 3-dimensional, we have to move down to the bottom where we see the content around cells and the organelles that make them function as a larger system, the science and engineering practice of modeling, and also the cross-cutting concept of structure and function. So this teacher used a prison analogy model to bring those 3 elements of 3-dimensional instruction together into assessing if a student is able to show how different structures in the cell relate to functions in the cellular system. So in the last 10 minutes, we've looked at how NGSS instruction looks different in terms of the teacher's role, in terms of how instruction looks in the classroom, and in terms of how students are assessed. In your exploration time, you'll be looking at a resource called the New Vision. It's not so new anymore since this came out in 2013, but it is probably new to you because so many schools do not have NGSS training. So take a look at the shifts from the NGSS website. A second resource that you'll explore is the NGSS screening tool. This is a large document, but take a look at page 2 where you'll see the features of quality design for NGSS lessons and the NGSS shifts. You can use pages 3 through 8 of this document where it talks about what lessons will look more like and less like, to think about some of the characteristics of your lessons and what they would be aligned with. And when you finish with those tasks, you'll use the Padlet as a discussion board to do this reflection. I used to think, now I think, and then you'll go and read some other job-alike home group reflections and respond. That is the end of Lesson 1, Module 1. Big thank you to Tri Association for sponsoring this learning, and we hope you enjoyed this experience so far.